Hey Geometry, welcome to your first set of video notes. While you're doing the video notes, make sure you use those skills that you learned in your How to Learn from a Video project, where you learned how to draw Bart Simpson. I learned how to make an origami crane, whatever skill you decided to learn. So in that project, we learned that we need to pause the video. You might need to rewind and watch things again. You might need to Google and look for a different video if this one isn't making sense to you. So our learning target for these notes is I can use the angle addition postulate to solve problems, including those with angle bisectors. So the definition of the angle addition postulate says, if K is in the interior of angle HIJ. So here's angle HIJ. K is in the interior. It's inside this angle. Then the measure of angle HIK plus the measure of angle KIJ equals the measure of the whole angle. So some things to note in here. When we have M and then our angle symbol, we read this as the measure of the angle. So we're not just talking about the angle, we're specifically talking about its measurement, how big it is. So angle addition is a lot like segment addition. So we have the measurement of angle HIK. That's this angle right here. Plus the measurement of angle KIJ, that's this one right here. If we add those angles together, we get that entire angle, angle HIJ. So it's like saying the small part on the top plus the bigger part on the bottom equals the whole thing. So in our first couple of examples for angle addition, in this first one, we are trying to find the measure of angle AOC if the measure of angle AOB equals 45 degrees. So I'm going to trace this out, angle AOB, that's this top one. I'm going to label it in my picture. This is 45 degrees. And I know the measurement of angle BOC, this bottom guy, that one is 20 degrees. So I'll label that in my picture as well. I'm trying to find the measure of angle AOC. AOC is the whole angle. So the first thing I'll do is write my angle addition statement. So in this case, my two smaller angles are the measure of angle AOB plus the measure of angle BOC equals the measure of my entire angle, angle AOC. In my next step, I'm going to substitute the information that I know. So I know the measurement of angle AOB is 45 degrees. I know the measurement of angle BOC is 20 degrees. I'm looking for the measure of angle AOC. So I can just add these together, and that whole angle is 65 degrees. Okay, example 2. This time, I know the measure of angle AOB is equal to x plus 10. So here's angle AOB. So this top part right here. So this is x plus 10. I know the measurement of angle BOC is 20. So from B to O to C, that's 20 degrees. And I know my entire angle, angle AOC, this whole thing, is 60 degrees. So when I label these, when I write my angle addition statement, I have the measurement of my two smaller angles. So the measure of angle AOB plus the measure of angle BOC equals the measure of angle AOC. In my next step, I'll substitute the information that I was given. So the measure of angle AOB is x plus 10. The measure of angle BOC is 20. And the measure of angle AOC is 60. So to solve this equation, I'm going to combine my like terms. So x plus 30 is equal to 60. So I would subtract 30 on both sides, and x is equal to 30. But that's not the whole problem. They also asked us to find the measure of angle AOB. So we can do this a couple different ways. I know that x is equal to 30. And I know that the measure of angle AOB is equal to x plus 10. So I can substitute 30 where x is, and I get my angle measurement of 40 degrees. The other way I could think about that problem is I know this whole thing is 60. So if the whole thing is 60 and this piece is 20 from angle BOC, well, then this would have to be 40. There aren't any other options. That must be 40 degrees. So that's angle addition, really similar to segment addition. I take two small parts, I add them together, I get the whole thing. So similar to the way segment addition has midpoints, when we have angle addition, we can talk about an angle bisector. And this is a term that we haven't talked about yet for angles. In an angle bisector, our bisector is a ray that's dividing the angle into two congruent angles. So if I know that ray XZ is the angle bisector of angle WXY, so this ray is bisecting this angle, then I know that it's going to create two congruent angles. It's cutting this angle in half. So this angle right here is congruent, is the same as this angle right here. So when we're marking angles as congruent, if I had congruent segments, let me just draw some quick segments here. I would mark them with my tick marks. We do the same thing to mark angles as congruent. So I draw in my little angle arc and then I add the tick mark onto it to show that they are the same. Okay, so let's name our two congruent angles here. Let's write our angle statement. My top angle is called angle, starts at WXZ. So I know the measure of angle WXZ is equal to, my second angle is this guy down here, angle ZXY. So if I'm talking about the measure of those angles, I would say they're equal to each other. But if I'm just talking about the angles, angle WXZ is congruent to angle ZXY. So when we talk about their measurements, we're talking about numbers. We're talking about things being equal. When we talk about just the angle itself, we talk about them being congruent. So let's do an example down here for this one, and then I'll have you try the second one on your own. So we know that QS bisects angle PQT. So QS is bisecting this angle. The first thing I'm going to do is mark on my diagram that these angles are congruent. So they both get the same amount of tick marks inside them. Because I know those angles are congruent, I can write my angle statement. I know the measurement of angle, the one on the bottom, is angle PQS, is equal to the measurement of the other angle, is angle SQT. So now I go back to my given information. Let's see what we got. We know angle PQT is 60 degrees. So that's this whole angle. I think that's a typo. That's totally a typo. I meant angle SQT. Yeah. Fix that in your notes. Angle did I mean that? No, it's not a typo. I take it all back. I'm so wrong. I have to learn how to edit my recordings. Not a typo. This is real life. Angle PQT is 60 degrees. So angle PQT is this whole angle. This whole thing is 60 degrees. If my whole angle is 60 degrees, what does that tell me about each of these smaller parts? Well, if the whole thing is 60, then these both have to be 30. They have to be. The whole thing is equal to 60. If I'm cutting it in two pieces, 60 divided by 2 is 30. So now let's substitute some information into our equation. I also know that PQS is 4x plus 14. So the measurement of angle PQS is 4x plus 14. I know the measurement of angle SQT is 30. So I can solve for x. I would subtract 14 on both sides. 4x is equal to 16. Divide by 4 on both sides, and x is equal to 4. They also asked us to find not only x, but also the measurement of angle PQS. Well, we kind of did that at the beginning. The measurement, I'm just going to roll with the yellow. The measurement of angle PQS is 30 degrees. So I could find that by substituting the 4 in where x is. Like I could make this a 4 and solve, but I already know that's 30. So try the second problem about the angle bisectors on your own. See how it goes, see if you get it, see if you can solve that equation. It's going to have variables on both sides. And then your job after watching this video is to work on, I think it's practice number 4, about angle addition.